So now we'll move on to the today's session. So today and tomorrow is going to be data structures, only stack concept. But in stack, like how we discussed in SQL, we are just going to see the general principle of a stack and many programs. So if you look at stack data structure, earlier we used to have stacks, queues, linked list, circular queue. In C++, when we dealt with C++, we had some three data structures we used to learn. The same stack using linked list, queues, we used to deal with these type of data structures. But now the syllabus is having only stack, and even the revised curriculum 2023 is also having only stack. So queues they have not included. So therefore, we will have to completely tell them about the different ways of testing the stack. So here again, we will be focusing more on question framing, and so that their logical skills will definitely improve by recalling whatever the concepts they have learned in class 11. So in class 11, they would have learned about int data type, float, strings, list, tuple, nested list, dictionary, everything. So here too, we are going to deal with all those. So in the curriculum, they would have very simply mentioned it as list implemented stack. So therefore, we will consider the list to act as a stack. So with that, we stop. But you cannot take the concept only to that extent, because we don't know, probably first year or second year, they due to the COVID situation, question paper may be very simple. But this may not be the case in future also. So we can't expect the list of integers to be tested. It can be a list of float, because the question says it is a list implemented stack. So obviously, I am going to represent a list as a stack. Okay, and we can't use tuple, etc. So here it is a list implemented stack, but that list element can be an integer element, can be a float element, it can be a name, list of names, it can be a list of list, which means nested list. I can have list of tuples. Every element in the stack can itself be a tuple. Every element in the stack can be a dictionary, or every element in the stack can also be a nested dictionary. So we can extend the complexity of the question. I have got few programs for the demonstration. From there, we are going to spread our ideas. Okay. So with respect to stack, right. So it is just about data structures. So as we discussed yesterday, from MySQL, we have 18 marks. Database connectivity is separately 2 marks that I am not bringing into MySQL. It is Python DB connectivity, so 2 marks. So 18 marks from MySQL and 5 marks from data structures. So for term 2 board exam students, this will be tested for 23 marks out of 35, and 10 marks from networks, and 2 marks database connectivity. That is all. So with that, our 35 marks is getting over for this term for the current board appearing student. Okay. So the type of the question that can be expected in section A. In section A, only one question, which is a theory question or an application question. Theory question or application question, which is for 2 marks. And in section B, there will be a program, which is for about 3 marks. So altogether, we will be having one theory or application question and one program. Okay. So before getting into the program, I'll come to the theory question. We will be just discussing. I found when I was setting the pre-board paper, I found a beautiful question. I actually enjoyed that question from the textbook. It is there in the Sumita Arora. So from there only exactly the same question only I gave. And take it for granted, the children will not be visiting the textbook. So how to make them go through the textbook? Again, let us pick up some questions from the textbook as well, so that they should not have any guess that no textbook will not be tested, or no only the sample paper questions will come. So let us not give room for students to judge us. They should not judge us. So they should always feel very contented when they see the question paper. Okay, I am able to attempt this paper. So they should get a sense of satisfaction. we will also get a sense of satisfaction when we set a paper. Okay. So now coming to the theory or the theory question. Before that, let's see what a stack is. A stack is a linear data structure. We all know that it works with the last in, first out principle only. And always the insertion operation and the deletion operation will happen only from the top end of the stack. So it is a list on one side of the list. The list is closed. It is like a closed pipe at one end, open from the other end. So the insertion and the deletion process of the list will happen only through one end, which is the open end, which we generally refer it as top end. Operations in a stack. What are the different operations that we can do in a stack? We can insert element in the stack, which is our push operation. We can delete element from the stack, which is said to be the pop operation. So it is just the insertion and deletion. We term it as push and pop. That is all. So nothing great about it here. Again, where will we do this push and pop? Naturally, one end of the list is only open. Therefore, which is the top end. Therefore, from the top end, we push and pop the element from the stack. Now, this is how your list is constructed. 1, 2, 3, 4, 5. And top is now, which is the top element? Number 5. Therefore, this is my stack. If we have to push above this 5 only, we will have 6. Therefore, now my top will be pointing to 6. Now, we also have certain terms related to stack. What are they? Peak, overflow, underflow. All these are some terms that are associated with stack. What is peak? It is just to check what is there on the top of the stack. That way, a peak is different from a display operation. Normal displaying the content of the stack will display the content from top to bottom. So if I am going to display the content as 6, 5, 4, 3, 2, 1, this is my display operation. If I'm going to print only 6, then it becomes my peak operation. It is just a term that is used in the textbook, and it is very commonly used in stack. When we speak about stack operations, what is peak? Peak is displaying, or rather we can even say that inspecting the topmost element of the stack is said to be peak. What is the difference we have between peak and pop? Peak is to display the element. That is all. Display the top element. Pop will remove that element permanently from the stack. So this way, we can make them understand clearly the difference between peak and pop, peak and display. Often they will get confused with these terms only. Okay. So peak is just to access the top element of the stack. So here it just tell us what is there as the top element. Say 6 is the top element. Coming to pop function, pop is to remove. It is not only accessing the top element, it also removes the element from the stack. Therefore, you will not have that 6 on the top of the stack because it is removed. It is accessed and it is removed from the stack. Now, what is there on the top of the stack is only 5. Okay, so this is about pop operation. So in connection to this, we also have two other terms, overflow and underflow. What is overflow? Overflowing means supposing, generally this overflow checking is not possible in Python because here we don't have we don't have array concept in the syllabus. Earlier, in other programming languages we used to have array, which is a static memory allocation. So there we used to fix the size of the array. Supposing if I declare the array size to be int a of 10, the maximum elements that can be stored in the array is only 10 elements. So there we have a chance to check for overflow. But here we can't do here in this case because list has no end. We can keep appending elements into the list. So we can't be checking for overflow. We cannot check for overflow condition. But I want my students to understand the concept of overflow. That is not possible with a list in Python, but it is there in other programming languages. So I want to give them this knowledge of overflowing. In that case, what I have done in my school is, I told them to accept the number of elements that can be stored in a list. So they used to get it in n. And as you are building the elements in the stack, you go for length checking. If the length of the stack reaches n minus 1, and when you try to push an element after it reaches its full length, in that case, maybe we can tell them to display overflow message. So that way we can still reach the concept of overflowing even in Python. But this is actually not required because in the sample papers at all, they have not taken up to this extent. And in most of the sample question bank or questions also, they are not testing for overflow. So once if they are comfortable with the stack concept, then we can take it like, no, this is what is overflow is. You need not use, but anyway, just to, if you want it, this can also be incorporated. You can tell them to do 1 or 2 programs using overflow condition. But in the exam, we will encourage students not to go for overflow because it is actually out of syllabus in our list cannot be checked for overflow. We are introducing the concept of overflow through some other channel for them to understand what overflowing means. That is all. So we will not insist on that, but we can gently tell them. So let us not deprive them from the original concept of stack, because originally in every programming language, overflow, underflow, push operation, pop operation, all these things are definitely there. So when they are going to do the same thing in graduation, most of the universities, they will be dealing with the C or C++ definitely in one semester at least. So in that case, it is going to help them. So coming to underflow condition is a definite condition to be checked in our programs. We have to definitely insist students to proceed with underflow checking whenever they do pop operation. So what is underflow? When we try to remove an element from the empty stack, it will lead us to an underflow state. So in that case, stack will be empty. So we are trying to pop from an empty stack. Therefore, it becomes our underflow condition. So these are the general terms that we use in stack. Okay. So now these things we would have learned in our graduation or in the post-graduation also. So in that, so now we'll move on to the programs. So we will just start with a very simple program, our sample paper pattern only. Now we have a question here, write, push, and with respect to this 3-mark question, it's a 3-mark question, and students will be asked to write a whole program, unlike C++. So in C++, they will be asked to write push function, pop function. They will be writing only the function definition. But here in Python, for 3 marks, they are asked to write one whole program. So the program weightage is actually lesser than the length of the program. I'll tell you the marking scheme also here, so that we will understand how the marking scheme goes here. So here we have write, push of movies and pop of movies. If you look at this, pop all in capital letters. If all in small letter, it becomes a built-in function. So we have to tell students to be very, very careful about the naming convention, because Python provides pop function for us. So it is a built-in function. So therefore here, very carefully it is given as capital pop. So that again, we need to instruct them in the class. So push of movies and pop of movies functions in Python to add a new movie and delete a movie from a list of movie titles, considering them to act as push and pop operations of the stack data structure. So therefore, we are going to add one title, movie title, they are going to delete movie title. So the stack is going to be list of movie names. Am I right? Delete a movie from a list of movie titles. So from this, we understand that it is, yes, the stack is now containing list of movie names. Okay. So, and what is this movies? Here it says to add a new movie and delete a movie from a list of movie titles. So therefore, movie is said to be my stack. Movies is said to be my stack. So therefore, coming to the main segment, we will start the program from the main segment. I have an empty stack. This empty stack should be defined only in the main segment. Now, repeatedly, we are going to call the push function to construct the stack. So we can make it as simple as possible. This is not the only solution. So whatever comes to your mind, if it is correct, then it is absolutely set to go. While true, push of movies, this is a function called to construct the stack. This will transfer the control to push function definition, wherein we are accepting the title of the movie, and the same thing is getting appended as an element in the stack. So list dot append function. That's what we are doing. Movie is my list acting as a stack. List acting as a stack. Okay. So now, excuse me, just a minute. So now in this case, we are adding the titles to the stack. So therefore, my now stack is constructed with movie titles. And after adding one title, as of now, only one title is added. Then we are taking the input from the user. Would you like to add some more elements in the stack? Depending on the choice. If I give yes, it is going to continue. If I give no, okay, so now here what we can do, one more statement is to be done if choice is equal to n or no, whatever it is, we can break. This is how it comes out of the loop. Okay, so then otherwise it's going to continue because it is while true. Therefore, we are going to again go back to the function call, take the second movie title that is now added in the stack. That way we keep constructing the stack. So where are we going to call the pop function? After this, maybe we can call the pop function again. While true, okay, we can call the pop function pop of the name of the stack. We are calling the function once. This will transfer the control to this function definition. We are checking whether the stack is empty. If it is not having, so there are two ways of checking the stack empty. This is if movies is equal to empty stack. Otherwise, if len of stack is equal to 0 or none. What shall we do here? Length of the stack is 0. Am I right? Okay. So stack is empty. Otherwise, stack empty, and we have to insist students to use the term underflow because we are trying to delete from an empty stack. So therefore, underflow. Otherwise, movies.pop, we are going to take out, remove one element from the stack. Now this pop function will not only remove from the list, it will also return that element. The element that is being removed will be returned by the function. So that is a return value for pop function. Okay, the element that is being removed from the list will be returned. So as it is returning, we are trying to delete that element. This is what is happening now. Okay, now with this, the topmost element is now popped. How long are we going to do the process? As usual, like how we put here, the same thing can be done here too. Okay, so if choice is equal to n, break. Otherwise, it's going to repeatedly show underflow. So this is just a way of doing a very simple program. So it is a, we are now working with list implemented stack containing movie names in it. So which means it is coming under the header stack with integers, strings we saw no. So it comes in this case. See, this case is now covered. Stack of strings. We just worked with stack of strings. So hope this is clear, or you want me to do it on the Python mode? If you want me to use Python, ideally, I will do that. Otherwise, we can. So here, if you look at the marking scheme, it's a 3-mark question. We have push function, we have pop, we have main segment. Push is 1 mark, pop is 1 mark, main is 1 mark. Now here, the probable areas where students will miss. First area, gray area will be movies is equal to empty bracket. This should definitely be a global declaration. What happens? They will do it once here in the main segment, and one more, they may do it in the push function. This is one, this is a very big mistake, which means the child doesn't know that it should be global. Stack can only be global because I can use that stack in push. I can use the same stack in pop or in the display function or in the peak operation. So this will be used throughout in the program. Therefore, stack can never be a local. So this is one area where definitely they will be going wrong. So 3 marks, very easily they will lose half. Very easy to lose mark because of the local declaration. Okay. And when you have a global declaration and local declaration will gain the priority because of that LEGB rule. Okay. Local environment variable will be taking its priority over the global variable. Therefore, stack, when it is defined for the second time inside the function, will definitely gain its priority as a local stack. Therefore, the changes that is happening in the local stack will not be reflected in the global stack. These two will occupy two different memory locations. So we have to instruct them. Okay. The second thing is, we know very well that list is a mutable data type. So when a list is passed as a parameter to the function, and if it is undergoing any change inside the function, the changes in the function definition, that is the changes in the formal parameter. This is what exactly I mean. This is my list. Movies is my list. List implemented stack, which is actually a global variable. One question logically, if a child has understood the concept of a local variable, global variable clearly, they will say, ma'am, you or sir, you have declared the variable to be a global variable. Then why should that be passed as a parameter to the function? And you say that the global variable scope is throughout the program. Then what is the point in taking it as a parameter? Because anything that is passed as a parameter is said to have local scope. Isn't it? Is said to have local scope. So therefore, this movies, what I am using as a formal parameter is different from my actual parameter. Am I making it clear? So the global variable movies is different from this. You want me to work it out? Will that be better? Yes, yes, teachers. Or if you're clear with this flow, I'll proceed as you wish. You want me to work it out? Yes, teachers.
No, ma'am, it's clear, ma'am. From the word itself, clear, ma'am.
Yes. So even if I'm going to make the name as just M, still it works. So here I will have to do M dot append dot. Here I will have to check M is equal to, so or length of M. Now, so here the formal parameter and the actual parameter are two different names. If you give the same name also, they are two different entities only. They are going to be two different variables. So therefore, anyway, the formal parameter has got a local scope. But here what happens, since the actual parameter is of type list, which is a mutable data type, the changes that you make in M will be reflected in the actual parameter movies. Because the formal parameter M is an alias name to the actual parameter here. Okay, so this happens only with respect to list. So therefore, here it doesn't matter whether you use the same name or a different name. So this is how we can convince the student. So formal parameter always has a local scope and the name doesn't matter in case of a formal parameter. It becomes an alias name to the actual parameter. So if the actual parameter happens to be a list, because of its original nature that it is a mutable data type, the changes we do in the formal parameter will be reflected in the actual parameter. Therefore, M dot append will see its reflection or the element will also be added automatically in movies because this M and the movies will be having the same address. Both M and the movie will be sharing the same memory address. So this is the explanation that we need to give them. Okay. So with that, shall we move on to the Next program, we have now seen or we have now explored how to construct a stack of strings just with movie names in it. Shall we move on to the next one? Or you want to take a view on this? Shall we proceed?
Yes, ma'am.
Yes, thank you, sir. Okay, so now here again, as I told you, if students are declaring local stack, they will be missing very easily half a mark. So that 3 marks becomes 2.5. Another area, they may not check for this underflow condition. They may simply pop the element. This is one another mistake they will do. Okay, so that is one thing. And so these two areas, generally they make mistakes. And properly they have to invoke the function by, they can have a loop here. If you look at this, the question says very clearly, write the functions to add a new movie, which means what? The question is directing us to add only one movie. Okay, the question is testing us to delete only one movie detail. But what children will do now generally, they instead of using the loop here, okay, we are doing the loop in the main segment such that we are strictly adhering to the question stating push and pop function is dealing with only one push operation of a title and one pop operation on the title. So only one movie is getting inserted and only one movie is getting deleted. But children will introduce a loop here. This is a very frequently mistake area. While true, they accept the title and they construct the stack. So instead of doing that in the main function, they may introduce a loop in the push function. They may introduce a loop in the pop function like this. So now here, if you look at this, very easily, they are losing their mark in local stack declaration. They will be losing their mark because of this loop getting introduced inside the function definition, because though this is correct, this is not adhering to the question. So board will test whether, so children may be knowing the concept of stack because they are taught only stack concept only. So they will be definitely doing correct push, correct pop, because for push, list dot append, for pop, list dot pop. So these two commands they will do correctly, but how are they using that command? Whether it is inside the loop or outside the loop, that matters. So very easily, if they are going to do looping within the push function, within the pop function, 1/2 a mark separately for push is lost, 1/2 a mark separately for pop is lost. Out of 3, very easily they are losing 1.5. So they will be left with only 1.5 marks for this particular question. And if they don't, in any other mistake, if they have not done, then they will be left with 1.5 marks. So they will be knowing, so they will have the satisfaction that, okay, I have done my program correctly, but it is tend to lose 1.5. So 50% of the weightage only they will be getting. So this again, we need to address them while teaching itself. This is the area which generally most of you will go wrong. So please go through the question. The question clearly says to add a new movie, so only one movie. To delete a movie, so so the function should take care of adding only one detail or deleting only one detail. So that way it is. Okay. So this is how we need to teach the students. So this is not a correct practice. So tell them to comprehend the question correctly. So what is very important with this data structure question is comprehending the question and recalling the class 11th portions, then implementing the class 12th stack concept. And again, break. If they use capital B, 1 more 1/2 a mark is gone. So it all depends that way. So let us be very, very conscious and strict in our correction also. So the next operation is again the same push and pop operation only, but here push and pop operations of a stack. So here in this case, this is a slightly different question. The same operation only we are doing, but in a different approach. I am going to make use of top variable, as we saw in the diagram, top was always pointing to the topmost element. So that is another way of doing the same program. So here, the same concept, how in different ways can be represented is the discussion about here. So now here, push stack of STK is my stack. And this is, I am going to now construct stack of integers. The first program was stack of strings. Now this is stack of integers. So here, every element in the stack is an admission number of a student. So here we are passing two parameters. Stack as one of the parameters, admission number, the element which need to be pushed into the stack is the second parameter. Okay. So now here, if you look at the main segment, I would have used two different variables for the formal parameter and the actual parameter. List is my actual stack. I'm going to now make use of top. So your question paper can even contain like this. Okay, make use of top, or they may give top to be the third parameter to be used in the program. So in that case, how are we going to handle the third variable or top variable? So this is an example for that. So top is a normal integer variable, which is now equated to none. So now this is a menu driven program. There is no hard and fast rule that we need to do only this way. While true, we are just going to have one push. This is our normal record program. One push, two pop, three display, four exit. We can even have four peak, five exit. So we can have four functions. Enter the choice. Choice is equal to 1. Take the admission number and then call the function by passing the empty stack and the admission number as a parameter. So the construction of stack is going to happen only inside the function push. You want me to increase the font size, or is this font size okay to all of you?
Visible, ma'am, it's visible.
Visible. Okay. So therefore, push stack of the list and the admission number, which is going to be inserted as an element in the stack, are passed as a parameter. Now here, if you look at it, my formal parameter of the stack is LST. The actual parameter I'm using is, my actual parameter is LST. My formal parameter is STK. My second parameter is admission number, it is a normal integer type data only. So it is already added. So in the earlier program, we accepted the element for insertion and we appended it. Now that the element is passed as a parameter, we are just going to append it. That is all. So this is a variation. So this is how we can test the different variations of the same question can be set, can be given. So we are just going to construct the stack by adding this admission number as an element into the stack. Now, where comes this top variable? Top is a variable which is always pointing to the topmost element. So how do we get the topmost element? Top is equal to length of stack minus 1, correct? Length of the stack is 1. Its index is going to be 0. Therefore, because the index starts from 0, we know that. So therefore, number of elements in the stack is as of now 1. So therefore, top should point to the index 0. That is why we have len of stack minus 1. Why should we have this global declaration? Global declaration indicates, so here we are not declaring STK to be a global variable or a local variable. It is a local variable, but we are necessarily making this top to be a global variable because STK is an alias name to the list, but whereas top is a normal integer variable. It is going to hold only an integer value, which is going to occupy a different memory location. Therefore, I want the global top to be updated so that the same top can be used in my pop function. It can be used in my display function. So therefore, top should necessarily be a global variable. So if I am going to define if I am given a chance, and we can't instruct students to write the program only in one way. I may write a program without using top, but the other student may use, say the child is an intelligent child and he wants to give his try. Why not I use a top? Anyway, I have understood the concept. You want stack operation to be done. I will do it by using a third variable top. So in that case, that should be definitely encouraged. So it is not like we have to teach a particular pattern of a program and children have to follow only that pattern. We will not do that. We have to encourage them to think differently. So global top is definitely must. This is one area which generally children will miss if they are going to use top. So therefore, half a mark is very easily gone in the absence of global keyword. If they're just going to have top is equal to len of stack minus 1, that becomes a local variable, and the changes or the updation that is happening in the push function for the top variable will not be reflected in pop function. It will not be reflected in the display function. So therefore, the main principle of the stack itself is collapsed here, if you are not going to declare it as a global declaration. So board will view this very, very seriously, and children will be missing, or they will be having higher penalty on this question if they are going to miss the keyword global. So we need to be very, very clear in case if the question is tested with global declaration, if they state any such things in the question paper as a part of the description, we have to train them to use this global variable. We have to train them or train students to write programs using top. Okay, so coming to pop function. Okay, then again we will come back to the main segment. This main segment says, again, if my choice is equal to 1, second time another admission number is taken, we are calling the function with that admission number. Once again, now this is my second element. Therefore, stack is getting added with the second element, and now your top is going to be 2 minus 1, 1, which means top is now pointing to the index 1. When I say top is pointing to 1, which means we have 2 elements. In 0th place, we have an element. In 1th place, we have another element. That way. Next is the pop function. Pop function is to delete an element from the stack. Again, top is undergoing change. Whenever top is altered, it should definitely be declared as a global variable. So as usual, we are declaring to be a global variable. Then before you actually start with your pop operation, check if the stack is empty. If the stack is empty, then you need to return underflow. Otherwise, return the element, okay, and then check, because you are deleting the element from the stack. When you're deleting the element from the stack, automatically the length of the stack also gets updated. So therefore, it becomes a responsibility to check for the length of the stack. Say, for example, I have only 1 element in the stack. Therefore, it will check if stack is equal to empty. It is not empty. Therefore, it will come to the else part. Now, if we have taken out 1 element. After taking out the element, now my stack is empty. That one, I had only 1 element. That 1 element is now removed from the stack. Therefore, it becomes very essential for us to reset top to none. To reset top to none. Otherwise, top is equal to length of stack minus 1. Just decrement the stack size by 1. And the element that is deleted is now getting returned from the function, because that is how the question would have been framed. Okay, we can either print that element here in the function, otherwise we can return that element depending upon the question. Next comes display function. In the display function, as we are not going to alter the top, global top is always optional. We don't have to put global top because top is not getting altered. Only when top is undergoing some modification, it becomes essential for us to use global top. Otherwise, it becomes a local variable. So just go ahead in checking if top is equal to none. If top is equal to none, we can't say that it is underflow. It is only an empty stack because we are trying to display the stack which is not having any element in it. Therefore, stack is empty. We can just stop with that. Here, underflow keyword should not be used, or underflow term should not be used. It's not a keyword. That term should not be used in display. That term can be used only on a pop operation. Next is, we have to display the elements of the stack. How do we display the elements from of the stack? It is not a normal list. It is a stack. Therefore, the elements can be viewed only from top to bottom. From top to bottom, it has to be in a descending order only. So we are going to iterate the loop as top, comma, minus 1, comma, minus 1. What is the value of top? My value of top is length of stack minus 1. Therefore, it will start from correct index, comma, minus 1 means top to 0. It keeps decrementing the index. So it has to be displayed only from top to bottom. That is why the loop is set from top to minus 1. So this is how we do push operation, pop operation, and display operation of the stack. So now here stack is constructed with list of integers. List of strings we have seen as the first example. List of integers is my second example. So this is the second version of the question. So this is another way of testing the question. So all possible ways of testing this particular concept in the board paper is our subject of discussion. Is this program okay for all of you? Any doubts in this, teachers? Yes, teachers? Or if you want me to execute also, I will do this. This has been shared with you already yesterday. Yes, teachers? Am I making it clear? Teachers, please respond so that if it is not clear, or if you want me to, or if you have any queries, please feel free.
Ma'am, it's clear only, ma'am, for us.
Okay, thank you. So one of the application of the stack is reversing a string. So here too, I have used stack and the string to be the parameters of the function. So starting from, say, the main segment, enter a string to be reversed. We are getting the string. Say, for example, it is level. Okay. So now level is going to be my string. S is my empty stack. Initially, top is equal to, now in the last case, we had top is equal to none. Now I am going to make top is equal to -1. Supposing they may give a partially filled program. So even we can, to increase their logical skills, if I want to test them in different patterns, we can even, in the school exams, we can even frame in the revision exams also. In the revision exams, we don't have to strictly follow the pattern of the board. If you want to really test their knowledge, we can even include partially filled code. I can say top is equal to -1. Then we can just put dash in between. So we can tell them to fill. So if I want them to necessarily use or do the program only in the way that I want them to do, you can give a partially completed code. Let them students fill the code. So that way we can improve their logical skills. So now in this case, I have top is equal to -1 for I in str, which means it is a string. So supposing when I have the string to be level, level. So now what I can do, I can just give them, okay, otherwise Python, let us take Python. Okay, for I in string. So I will be having P, then Y, then T, H, O, N. Every character is now taken through this loop. Now each character is passed as a parameter to the push function. Now here, I am not going to have list of strings. This is a different version, list of characters. Every element in the stack is a character now. So the character is represented using C in this case. So I am going to pass I as a parameter that is now stored in C. C is also an alias name to the I variable that is getting appended to the stack S. Okay, as we are constructing S, which is my formal parameter that gets reflected in my actual parameter S. So top plus equal to 1, we did in the last program, we did that inside the push function. Now I am doing it in the function call. This is a variation. It can be done anyway. If you are going to do this process, okay, inside the push function, then it becomes essential for us to declare top to be global top. Otherwise, here in this program, I don't need it because top is anyway getting incremented only in the main function. So it becomes accessible to all the functions of the program. So therefore, this is the third variation that I am trying to show you. Okay, so program can be done in different methods that we all know. Now coming to the pop function, check if top is equal to -1. We did in the last program, we did this underflow checking inside the pop function. Now, my push function and pop function is only doing the process of pushing and deleting an element. Putting an element into the stack and deleting an element from the stack. That is all it is doing. Rest of the operations are all done in the main segment. This is the third variation. We are doing it here. Okay, underflow checking and break. If it is an underflow, I am going to come out of the loop. There is no point in proceeding with pop operation. Otherwise, print with the function call. Printing with the function call, what happens? This particular function call is returning the element that is deleted. Now the objective is to reverse a string. Python is my string. So my list would have been constructed as P, Y, T, H, O, and N. So when you are popping the element from the stack, N will be the topmost element. N will come out, then O will come out. So when every element is coming, taken out from the stack from the last, automatically we get the reversal of the string, isn't it? So that is why reversing string is one of the application for stack. So as because top is used in the main segment directly. Top is getting updated in the main segment. If it is the same updation is happening in the function definition, then we may have to give global declaration, otherwise not required. So we have taken three different, we have seen three variations in the same concept. Same concept only. Push and pop happens only at the top end. But see, look at the way we differ with the programs. So now we'll just, so this is all the different variations we have seen, and we can take case by case can be discussed actually. So here, today and tomorrow, to just start with today, we will be discussing at least one question, say push function taking list of names as parameters and complete the program with other required operations like push function, pop function. But the question says you have to do push function with the list of names as parameters. So therefore, I'll just open this first program alone. So what I had in my mind, method 1 and method 2, I have chosen here. So here the source is list of names to construct the stack. Okay, so my stack should have name as its element. Okay, so stack and the name should be taken as a parameter. So s dot append of name. Pop function is only doing underflow checking and doing the pop operation and returning the element that is being deleted from the stack. If you look at the main segment, my source list is empty. Okay, now here, how many students I'm going to, so now this is my list. See, you're going to take the list of names to construct the stack. What do you mean by that? Already, I have created a list. Are you getting me? It is not that the stack is going to have list of names. Of course, it is going to have list of names in future. But what is your source? Your source is not a single string. I am going to pass a list itself as a parameter. If you look at this, the source is going to be the list of names. Using this list, I am going to construct another list which is going to act as a stack. Are you getting me? So this is a slight variation in the question. Same program only, but the program would have been started in a slightly different instruction. So here the question says, take the list of names as parameter. The question is here. I'll come back to the question. Taking list of names as the parameter. So therefore, I am going to take the list of names. First, you have to construct the list. Initially, my source list is empty. My stack is also empty. Okay, I am now going to create the source. How are we going to create the source? Construct the source list. Okay, source list is constructed as list dot append dot. So now when you are coming out of this particular loop, we would have constructed a normal list of names. Am I right? We would have constructed a normal list of names. Now, but the question says you take list of names as parameters. So which means even I went wrong here. List of names as parameter means ideally I should have called the function as push of s underscore lst according to the question. Am I right? I went wrong in this question. So this shouldn't be this case. It should be like this. Okay, so I'll just comment it. So therefore, source list is taken as a parameter. Okay, now my name, okay, now this is my list of names. Am I right? List of names. So here what I can do, if I want to finish my push function for I in L underscore name. So you can very well, because L underscore name is my list of names. Am I right? Here, S dot append of I. So I am now creating from a list, you are constructing a stack. So it is, so we are creating another copy of the same list. That's what we are doing. The first one is a normal list. The second one is a list implemented stack. Am I making it clear? So since the source is a normal list, we can operate it from the index 0 to n minus 1. We are accessing the elements of the source list from the first element. Okay, but when it comes to the pop function, we have to pop it only from the top element, because destination is not a normal list. Your destination point is a stack. Stack can only be operated from top to bottom. But here in case of push, my list is a normal list. It is not a stack implemented list. Okay, so therefore, this has to be accessed from bottom to top, but whereas your pop function should be accessed from top to bottom. So this is what we have to make it very clear to the students. Okay, so let's run the program. How many students? Say I have 3 students. So your original list is AA, BB, and CC only. But your stack is having CCC to be the topmost element. So which is coming out first? Triple C. After accessing triple C, you will go to triple B. Then we'll go to triple A. So your source is your normal list. Destination is your stack. So here again, my stack is constructed with a list of names only. But how it is taking the data? The first program, if you can recall, we accepted one name, we inserted that immediately in the stack. Then we accepted the second name, we pushed it into the stack. Then we took the third name, we immediately pushed it into the stack. So the stack was constructed by taking element by element. We did not store those elements as a list. Now what I am doing, why should I take and immediately push it into the stack? Let me push that into a normal list. From the list, we are going to access the element. Supposing you have a list of some data, how do you access it from the list? That becomes my normal list. The destination is my stack, which should be strictly following the principle of last in, first out. So this is my method 1. Okay. So we have the same program, method 2. Yeah, this is what we did now. Are we using top element? No. There is a variation here. I'll just take the okay, so here we have a display function in method 2. Yes. Not great difference. I have included display function, and this is to see from how we display the element from the stack. We display the element from top of the stack to the last element in the stack. The last element is the first inputted element. Okay. So now here S is equal to empty bracket. The top element is length of S minus 1 till minus 1 minus 1. So I have just included one display function here. That's all. The list is passed as a parameter, stack is also passed as a parameter. That is all, same thing. Okay. So here and there some one or two instructions only will be different between method and method. So we have to instruct the students to comprehend the question in a correct way. Comprehending the question is very important. Now, so now all these things are very simple programs. If you come to the next question, write a program in Python to take a list of student names as its parameter and display only those names that contain the alphabet small e or e. So we can impose some conditions like this. So this way slightly we can we can complicate the question. So in all these programs, what we saw was only pushing and popping operation. There is no condition. Now what are we doing? You take a list of student name and display. So which means what? A normal list stack need to be constructed by taking the student names as elements in the list. But while displaying, we are not going to pop. The question is testing is to do push operation and display operation. So how are we going to display? While displaying, I don't want to display all the elements from top to bottom. Instead, display, you are going to visit from top to bottom, but display or print only those names that matches this condition.